This lesson is proudly brought to you by Kagiso Trust in partnership with the Limpopo Department of Education and Capricorn FM. Kagiso Trust, overcoming poverty.
Class is in session.
Ding, ding, ding.
Totally, we need to get a school bell.
Yeah, I think so.
Just for this segment of the show.
I am all for that. I'll get it. I'll get it.
7 minutes after 5. Get Capricorn FM, Limpopo's hottest frequency. Just drive Dean Komani to Banda. Catch up lessons. Hashtag Kagiso Radio Teacher. We are back in class, of course, today. And we are going to be taking a look at mathematics. Oh, I'm not going to lie. Welcome to the show, first of all.
No, thank you.
Well, I get a welcome back because
thank you.
This is your second time making Mr. Mpia. I'm going to be honest. The
both of us. Maybe that's why we are called the A team.
You've been called the B team, C, E,
D
F
team.
team. So we're going to be getting into mathematics. I'm encouraging all the grade 12 learners right now who are taking mathematics as a subject to pay close attention. Grab your pen, paper, calculators, your question papers. Also alert your friends to tune into Capricorn FM right now, wherever they are. And then if you've got any questions for our Kagiso Radio Teacher, feel free to send us your WhatsApp to the number 082-654-2446. Sir, the floor is yours.
Today is the 20th of May 2020. Welcome, Capricorn FM listeners, especially grade 12 class of 2020. May I also take this time to thank Department of Education Limpopo, Capricorn FM, Kagiso Trust for affording us a chance to learn mathematics. I am Marubeni MF from Tengwe High School. Today's topic is Euclidean geometry. It is our second day when we are doing Euclidean geometry. We also did Euclidean geometry on the 16th, that was last Saturday. We discussed the following things. Number 1, allocation of marks. Number 2, we have gone through examination guideline. We did, I also gave you the theorems that are required to be proved in examination, and also gave you acceptable reasons when you are proving Euclidean geometry. Number 3, we also did revision from grade 8 up to grade 11. We managed to do one theorem and also give some basic terminology in circle geometry in grade 11. Number 4, I also gave you homework. There are 2 problems that I gave you. I'm going to start with those problems. Before I do anything, let me read through this problem. Problem number 1. AB is a chord of a circle center O. D is the midpoint of AB. AO and DO are joined. AO is 10 centimeters and AB is 16 centimeters. Calculate the length of OD. If you check here, you are given a circle and you know how to name a circle. We name a circle according to the center or the points on the circumference of a circle. So what I'm going to do here, we are given circle O and you know that the chord is AB. Then you are supposed to join the following. We said you are joining AO and also OD. Therefore, we know that D is the midpoint of AB. If D is the midpoint of AB, it means that AD is equals to DB. You may not understand this properly if you don't use a pen and also a book. You must make it a point that whenever we're talking about a circle, make it a point that you also draw that circle. In other words here, we have a triangle. You know that if a line drawn from the center to the midpoint of a chord, it is perpendicular to the chord. Therefore, it means angle ADO is 90 degrees. Let me repeat. It means angle ADO is 90 degrees. Therefore, we remain with a triangle, which is a right-angled triangle. The name of a triangle is triangle AOD. Triangle AOD, where there is 90 degrees. Remember, whenever we have a right-angled triangle, it means we are going to apply a famous theorem of Pythagoras, where we say hypotenuse square is equals to sum of two sides square. So let me give you the letters in terms of the letters. If suppose maybe you struggled in terms of drawing this cycle, it means AO squared is equal to AD squared plus OD squared. In other words, OD squared, OD is hypotenuse side. It is the longest side. I'm saying OA squared is equals to AD square plus OD square. Remember, we have to replace everything. We know that the value of OA is equals to 10. And we know that AB is equals to 16. Since D is the midpoint, therefore, AD is equals to 8. Therefore, in the formula, we are going to replace AD by 8 and we square that one. Remember, 100 when we square it, 10 when we square that one, it will be 100. 8 when we square that one, it will be 64. Therefore, you make OD squared subject the formula, and 100 minus 64, it will be 36. When you get the square root of OD squared and square root of 36 here, you get OD to be 6. OD is going to be 6. So if you struggled, make it a point that you write this OD to be 6. Then you can be able to do everything. May I also remind you about theorems, of which their proofs are needed for examination purpose. Still, I am reading from examination guideline on page 7 on examination guideline. Let me also read some theorems that are needed for examination purpose. I'm saying this if you missed the first lesson. Make it a point that you need to have a pen and also a book to write on or a paper so that you can be able to know all the theorems that are needed in examination. Number 1, it says the line drawn from the center of a circle perpendicular to a chord bisects the chord. The line drawn from the center of a circle perpendicular to the chord bisects the chord. Number 2, the angle subtended by an arc at the center of a circle is double the size of the angle subtended by the same arc at the circle. Or you may say, remember that they should always be on the same side. Number 3, it is opposite angles of cyclic quadrilateral are supplementary. And I hope by now you know that when we talk about supplementary, you know that when we add them, the total, it will be 180 degrees. Number 3, I said, the opposite angles of cyclic quadrilateral are supplementary. Number 4, the angle between the tangent to a circle and the chord drawn from the point of contact is equal to the angle in the alternate segment. Let me repeat. The angle between the tangent to a circle and the chord drawn from the point of contact is equal to the angle in the alternate segment. Number 5. I think number 5 and also number 6, we are going to do them the next day. Probably that is next Monday. So make it a point that you revise all these theorems, since you know that in examination, like I said, at least one will come. So make it a point that you revise them so that you must get marks. If you still remember, I gave you 2 problems as a homework. Let me also do the third one. But if you still remember, I also mentioned the third one where I said you are supposed to prove this in examination. Let me read. It says, the angle subtended by an arc of a circle at the center is double the angle it subtends at any point on the circle. In other words, we are saying the central angle is twice the angle on the semicircle, or the central angle is double the inscribed angle subtended by an arc, or by the same arc rather. So in other words, we are talking here about the central angle and also the inscribed angle. When we talk about the inscribed angle, we are referring to the angle that we find on the circumference of a circle. So, you know that we cannot prove this if we do not have a diagram. So make it a point that you also use your pen and also a book to write on to sketch this diagram that I'm referring to. Here, we are given a circle. We are given a circle. In other words, the circle, we say the center is O. The center is O. In other words, since the center is O, we say it is circle O. In this circle O, we have a central angle. Since you know that the center is O, on the circumference, we've got B and also C. We find B and C on the circumference of a circle. And again, on top of that, we have angle A. In other words here, we have circle O, where we have got A, B, C on the circumference of a circle. So what I'm going to do here, remember, whenever you're supposed to prove any theorem, you are supposed to tell us the given information based on the drawn diagram. You must give us the given information based on the drawn diagram. Let me start here and give you the given information. We may say we are given circle O. We are given circle O with central angle BOC. We are given circle O with central angle BOC. And we are also given inscribed angle. Remember, when we talk about the inscribed angle, it's also the angle that we find there on the circumference of a circle on top there. And that inscribed angle, it is angle BAC. Can you draw that one? I think it is much easy. Remember, both these angles, BOC and angle BAC, they are subtended by an arc. And that arc, we call it BDC. BDC, that is an arc. What are we supposed to prove? Remember, we are supposed to prove that the central angle is twice angle on the circumference. So what are we going to do here? We are going to give the given information based on the diagram. Based on the diagram. We need to interpret this one based on the diagram. How are we going to say this one? In other words, we are supposed to prove that angle BOC is equal to 2 angle BAC. 2 angle BAC. In other words, we are supposed to prove that angle BOC is equals to twice angle BAC. Then, you know that when you are supposed to prove here, there is a need for a construction. You are going to join AO and produce that one to E. You join AO and produce that one to E. Remember, all the angles that we have on the left-hand side, let's name them 1. We know that on the circumference there, since we have already separated by a constructed line, we've got 2 angles there. And we're going to rename those angles. The first one, it will be A1. The other one, it will be A2. On the left-hand side, it is A1. On the right-hand side, it is A2. And again, in the central angle, and angle O1, it is on the left, and O2 is on the right. What I'm going to do here, we are supposed to start with a proof. Remember, we are going to say angle A1 is equal to angle B. If you check, A1 is equal to angle B. Is it possible? Yes. Why? Because BO is a radius and also AO is a radius. In other words, based angle, they need to be equal, since they are the based angle of an isosceles triangle. Make it a point that you understand that one. So again, we know that angle O1 is equal to angle B and also angle A1. Angle O1 is equal to angle B plus angle A1. Reason? Exterior angle is equal to sum of opposite interior angles. Exterior angle is equal to sum of two opposite interior angles. So, similarly, we know that O1, therefore, since angle B and angle A1, they're equal, we know that angle A1 is equal to 2 angle A1. Therefore, if we do in the same way, we'll also find that A2 is equal to twice angle A2. O2 is equal to twice angle O2. Therefore, if we check O2, is the same as angle BOC. If we check angle A is the same as angle BAC. Therefore, we have found the proofs to be correct. So remember, there are 3 sketches that are normally provided in any of the textbook that you can have. Make it a point that you master all those sketches. All those 2 problems that I've done, those were the problems that I gave you as a homework. Remember, there are other theorems of which you are not supposed to prove them in examination, but you need to understand what those theorems they implicate in mathematics. Make it a point that some theorems, you have to know them, although you may not be required to prove. Examiner may not ask you to prove these theorems. Let me try to add some of those theorems that are not even necessary for you to prove in examination. The first theorem, it is if you are given a circle and there is an angle that has been subtended by a diameter. If there is an angle that has been subtended by a diameter and that angle is 90 degrees. Sometimes people, they may say angle in a semicircle. Let me repeat. If you can have an angle that is subtended by a diameter, you are not requested to prove it, but you need to understand that as long as it is subtended by a diameter, the angle that has been subtended, it is 90 degrees. I hope you won't forget that one. That is number 1. Then, we also have another one. We have the second one. The second one, we are saying, if the angle subtended by an arc or a chord of the circle are on the same side of the chord, then the angles are equal. We are saying if the angle has been subtended by the same chord, angles have been subtended by the same chord, it means the angles are equal. Whenever you have 2 angles that have been subtended by the same chord, so those angles are equal. let me remind you, what was the first one of which you are not supposed to prove? Any angle that has been subtended by diameter is equal to 90 degrees. Number 2, we are saying if there is two angles that are subtended by the same chord, those angles are equal as long as we find them on the same circle. Number 3, it is also driven from the previous one. If ever you can have the angle that are subtended by equal chords in the same circle, angles that are subtended by equal chords, those angles are equal. When you have angles that are subtended by equal chords, those angles are equal. Number 1, subtended by the diameter. Number 2, subtended by the same chord. Number 3, they are subtended by equal chords. Remember, all those previous theorems that I've mentioned, we are going to use them when we prove the theorem that follows. The theorem that I'm going to prove now, it is a theorem whereby the proofs are needed for examination purpose. Make it a point that you master them. Number 1, it says, the opposite angles of cyclic quadrilateral are supplementary. The opposite angles of cyclic quadrilateral are supplementary. I hope by now you understand that if we talk about supplementary, we are saying when you add them together, the sum, it will be 180 degrees. What are you going to do here? Make it a point that you draw any quadrilateral. Remember, when we talk about a quad, we are referring to any four-sided figure. A quad is any four-sided figure. So, since we are going to prove that opposite angles of cyclic quadrilateral, when we talk about cyclic quadrilateral, we are saying it is a quad that we find in a circle. It's a quad that we find in a circle. What are we going to do here? In order for us to prove this one, we have to make it a point that we name them orderly. We are going to name this cyclic quad to be A, B, C, D. Quad A, B, C, D. Remember, we named them according to that order, regardless the direction that we're taking. As long as it is in that direction, you have to name it that way. But remember, on this one we're saying, the center of the circle is M. The center of the circle is M. Then, if the circle is M, in other words, we are going to join 2 points, 2 lines rather. That is BM and also MD. BM and also MD. So we're going to continue later.
Alrighty, it is 5:30 right now. Capricorn FM News Headlines and Shamuno Marule, and then Kamarano Namolani will follow shortly with Capricorn FM Sports.
Mall of the North is here for you. Now you can stock up on even more essentials like stationery, plus selected homeware, footwear and clothing just in time for winter. Get your to-do list sorted with optometrists, banking and cellular services all conveniently under one roof. We're also here to make your shopping experience safe. Remember to wear your face mask and practice social distancing when you visit. For more about how we're safely supporting our shopper community, visit mallofthenorth.co.za and social media.
News headlines on Capricorn FM.
Let's look at newsmaking headlines now. The Capricorn District Municipality has committed to helping the Marakalala family with funeral costs as they prepare to bury their murdered daughter. The Collins Chabane Municipality says it is proud to become the first local municipality in the Vembe district to have put plans in place in safeguarding the lives of their employees and of citizens against COVID-19. And Public Enterprises Department says it has directed Danell Management to use resources within the company and ensure that employees receive their May salaries. Your final bulletin at 6 p.m.
Capricorn FM Sports, on and off the field. We've got you covered.
And now for your final look at your sports
Keeping you
today.
up to date.
SuperSports United defender Grant Kikan has teamed up with teammate Aubrey Mudiba to help provide people in his community with food parcels. Kikan was today in Bela with teammates Ronwen William, Boale Fapule and Orlando Pirates legend Edward Mutale at the municipality offices to help with the official donation of masks and other essential goods. Many South Africans are struggling to feed their families during the coronavirus pandemic, and this has seen athletes all over the country doing their part to help their communities. Kikan says he felt it only right for him to give back to the community where he was born and raised.
This is where I was born and raised, so I felt the need that I needed to come back to my home because I know I lived here for a long time and I know the struggles that they face here. So I felt it only right for me to also do something of this sort in my hometown. And today, I think I was a bit emotional because I saw there's actually a lot more people that are struggling than we thought they were. So it's only a start, hopefully.
The 27-year-old also thanked his teammates for their support, who came in numbers to distribute the food parcels.
I'm just really also thankful to Aubrey, Ronwen, Boale Fapule for coming through with me and helping me do this initiative at home.
Meanwhile, Liverpool manager Jurgen Klopp has backed the Premier League's plan for players to return to training this week. Players are returning to training after the clubs voted unanimously to do so at the shareholders' meeting on Monday, the first significant step in the return to play protocols. Officials are optimistic about the Premier League restarting in June, 3 months after football was suspended due to the coronavirus pandemic. But there's an acknowledgement that plans may not be sufficient, or rather sufficiently advanced, to ensure a return to action on June 12th, as initially hoped. The Premier League confirmed on Tuesday it had received 6 positive tests for coronavirus from 3 clubs after the first phase of mass testing. A total of 748 tests were carried out over the weekend, while some Premier League clubs resumed training in small groups on Tuesday, and Klopp believes the timing is just about right.
I couldn't wait for a while now. I'm really happy that we are able to do this again. Going back to my word, having small group training, stuff like this will be intense for the coaches, especially because we have a lot of players in small groups, means a lot of sessions, but that's we had enough time to rest, so that we will be fine. It will be good fun for the boys. They can't wait as well. It will be passing, it will be turning. No challenges allowed, so we will not do challenges, obviously, which is a big part of football, but will not have minutes. We were already creative and we will be creative.
And finally, in racing, McLaren boss Zach Brown believes Daniel Ricciardo is now convinced of the team's progress and future prospects 2 years after turning them down. The working team identified Ricciardo as 7-time Grand Prix winner as the man to replace Carlos Sainz once it became clear that the Spaniard might move to Ferrari. McLaren held talks with Ricciardo when the Australian was last in the final year of the contract 2 years ago, but the Australian instead chose to move to Renault from Red Bull at the end of the 2018 season. Renault finished in the promising 4th place with nearly double the points of McLaren at the time.
Yeah, I think getting a Grand Prix winner like Daniel definitely is a sign that we're going the right direction. He believes in that. We went after him a couple years ago before he made the decision not to join us. And I've talked to him about it, and he went, you were coming off a pretty poor season, which is putting it politely, but also there was a lot of this is what we're going to do to rebuild the team. I hadn't brought in yet Andreas Seidel or James Key or restructured the leadership team, so there was a lot of promises, and coming off such a bad season, I could see how he would go, let's see how this plays out.
But after a turnaround in respective fortunes in 2019, when McLaren took 4th by a comfortable margin and signed several key deals, including a Mercedes engine supply for 2021, Brown believes that Ricciardo has brought into the game, or rather into the team, long-term plans.
He's liked how it's played out. I've liked how it's played out, and so I think now he's seen with the changes we've made, the leadership Andreas is brought, and the backing we have from our shareholders, going to the Mercedes engine, that we're a team on the move, and I think he's going to help get us to the next level.
And this is all your sports for today. I'll be back with more tomorrow morning on the Go Breakfast with Complexion in Mpomashita. For more updates, follow at Capricorn FM News on Twitter. And for Capricorn FM Sports, I am Gamorelo Namalani.
keeping you up to date with the latest sports news. Capricorn FM Sports.
This lesson is proudly brought to you by Kagiso Trust in partnership with the Limpopo Department of Education and Capricorn FM. Kagiso Trust, overcoming poverty.
Sorry to Kamal. I made a mistake there. I'm so sorry.
He'll
man.
be fine.
He'll be fine, right? All right, we continue with our class for today. Mathematics, of course. Mr. Mpia is still here with us. Lessons. Marubini. Yo. And I'm so confident when I'm saying it. It's Mr. Marubini giving us lessons on mathematics. So if those questions are still there, do keep them coming through 08265424446. Just bear in mind that the questions that Mr. Marubini will not be able to answer in the short time that we've afforded him, he will be able to answer them when he comes back for the next lesson. So your questions will not fall on deaf ears. We will forward them to Mr. Marubini's personal contact, and then he will deal with them and probably attend to them when he comes back for his next lesson. You may continue, sir.
I was doing the theorem opposite angles of cyclic quadrilateral are supplementary. Let me remind you that it is not possible that I can do properly all the theorems in an hour's time, since you know that for us to finish Euclidean geometry, we have to spend almost 2 weeks. So what I'm going to do here, I'm going to give you the highlights, the most important things that you have to learn, especially when you're doing Euclidean geometry. Like I said, we're going to draw a quad. A quad, we're going to name it orderly. It is A, B, C, D. In other words, these are the points on the circumference of a circle, and that circle is M. Remember, we are going to name the top part to be M2. Bottom part to be M1. We know that since when we prove, we are going to use the previous theorem. So what I'm going to do here, we know that M1, it will be a double angle to angle A. Double angle A. And if you still remember, it's an angle at the center is twice the angle on the circumference. In the same way, M2, it will be twice angle C. But when you add M1 plus M2, it will give you 360. Therefore, when you add them together, it means M1 plus M2, it will be 360. When you add with 2A and also 2C, when you divide there, the answer that we get, it will be 180. I know that I've been trying to explain very fast, but I know you are going to use a textbook for you to master that. May I also continue with the theorems that their proofs are not needed in examination. If you still remember number 4, it says the exterior angle of a cyclic quadrilateral is equal to interior opposite angle. The exterior angle of cyclic quadrilateral is equal to interior opposite angle. You must make it your point, you master that one. Remember, after we have done cyclic quadrilateral, there are some key points that one need to understand, especially when you are working with circles. Number 1, the sum of pairs of opposite interior angles is equal to 118. In other words, we are saying the sum of opposite interior angles is equal to 180. In other words, they are supplementary, as we said previously. Number 2, an exterior angle of quadrilateral is equal to the opposite interior angle. Exterior angle of quadrilateral is equal to the opposite interior angle. This is the information, or rather, that is the information that we're going to use when you are asked to prove whether a quadrilateral is a cyclic quad. When you are given a quadrilateral, that you are supposed to prove that indeed is a cyclic quad. Number 3, a side of quadrilateral subtends equal angles at the opposite vertices. In other words, we can say angle in the same segment. Angle in the same segment. Let me repeat. A side of quadrilateral subtends equal angles at the opposite vertices. So let me revise 3 things that one needs to look at when you are asked to prove whether a quadrilateral is a cyclic quadrilateral. Number 1, if you can prove that opposite angles, when you add them together, they give you 180, you can conclude that it's a cyclic quad. Number 2, if we can prove that exterior angle of quadrilateral is equal to the opposite interior angle, then you can also conclude that indeed is a cyclic quad. Number 3, a side of quadrilateral subtends equal angles at the opposite vertices, or angles in the same segment, that you need to make it a point that we can prove them. Those are the 3 things. Actually, if you check any question paper, you would find that at least you will have a question that will be asking you to prove whether it's a cyclic quad. So make it a point that you master all those 3 points whenever you are given a rider. Then, since I told you that there are theorems that one need to prove, let me give you the last one that you are supposed to prove. And I hope you are going to make it a point that you write at least a diagram on this one so that you can master this one. The angle between a tangent and a chord is equal to the angle in the alternate segment. Sometimes we call this one a tan-chord theorem. The angle between a tangent and a chord is equal to the angle in the alternate segment. Remember, whenever you give us, or when you put down a given information, you must give us the given information based on the diagram that you are going to give in examination. You give a given information based on the diagram that will be provided in examination. Let me give you a triangle. It is triangle BAC. All those 3 points that I've mentioned, they are found on the circumference of a circle. There is point BAC. They are all on the circumference of a circle. If we check them, on the point A, we are going to draw a tangent. But I hope you still remember when we said that a tangent will only touch a circle at one point. A tangent will touch a circle at one point. In other words, it won't intersect whereby it will have 2 points. It will be just 1 point. I am saying that tangent, it is drawn and it passes, or it cuts at a point A where we have a triangle BAC, and BAC are the points on the circumference of a circle. Remember, what are we given here? You can write it this way. Remember, we are going to say the tangent, it is named as DAE. DAE. It is DAE. And remember, the center of the circle, again, we are going to name it to be O. The center of the circle, we are going to name it to be O. What are we going to do here? We are given DE is a tangent to a circle, center O at A, and B and C are the points on the circle. We are supposed to prove that this angle that we find between the tangent and the chord AC and AE, we name it 1. In other words, we're going to say you are supposed to prove that A1 is equal to angle B, A1 is equal to angle B. From here, we are going to do construction. We are going to construct a diameter that is AOF, and connect F and C. We connect F and C. When you are supposed to prove here, I'm going to do this one very fast. You are going to name the interior angle between the diameter and also chord AC to be 2. Therefore, you are going to say A1 plus A2 is equal to 90 degrees. Reason, radius is perpendicular to the tangent. Radius is perpendicular to the tangent. And again, we know that angle FCA is equal to 90 degrees. FCA is equal to 90 degrees. Why do we say it's 90 degrees? It is angle in a semicircle. If you didn't forget, we are saying that is the angle that has been subtended by a diameter. In this case, the diameter is FOA. The diameter is FOA. So, since if you check properly, since FCA is equal to 90 degrees, it means angle F is going to be 90 degrees minus A2. And again, angle A1 is going to be 90 degrees minus A2. Therefore, angle A1 and also angle F are equal. I know we may have different ways of proving the same theorem. What is important, make it a point that you go through your textbook. Make it a point that you go through your textbook so that you can be able to master everything. Then, let me also continue with the theorems that you are not supposed to prove in examination. I think now I'm in theorem number 5, the ones of which the proofs are not needed for examination. Here's the theorem. It says, a tangent to a circle is perpendicular to the radius at the point of contact. A tangent to a circle is perpendicular to the radius at the point of contact. In other words, if you are given a circle and you draw a radius, you also draw a tangent that passes through that point. Then we say the radius and also the tangent, they are perpendicular. When we say perpendicular, in other words, they are going to form 90 degrees. Those two lines are going to form 90 degrees. And there is no need to learn the proof for this theorem, since it won't be asked in examination. Let me go to the last one. In the last one, you are given that two tangents drawn to a circle from the same point outside the circle is equal in length. Two tangents drawn to a circle from the same point outside the circle is equal in length. In other words, if we can draw two tangents and they meet outside the circle, the length from the point where they meet and also the point of contact to a circle, they are equal in length. Let me repeat. I'm saying two tangents drawn to a circle from the same point outside the circle is equal in length. In other words, we are saying when two tangents, they meet outside the circle, from the point where these two tangents are meeting up to the point of contact to a circle, their length, they are equal in length. They are equal in length. Remember, in Euclidean geometry, it will be balanced paper, as I said before. I said you will be expected to prove in examination where you'll get 10, maybe plus or minus 6 marks. You can get plus or minus 6 marks when you are supposed to prove. And all those theorems that are going to come in examination for proving, they are found in those 6 theorems that I mentioned. Then, you know that probably the first question, it will be the simpler question, whereby you will be expected to get the magnitude of angles. So it will be much easier. Remember, there should also be 2 questions, one based on the work in grade 11 and also based on the work in grade 12. The one that I said in grade 11, you will see where you are supposed to prove whether this quad is a cyclic quad like that. You will be doing the work that I've been mentioning today. So, I know that there will be a lot of problems. What I'm going to do with you here, I'm going to give you some skills that are going to assist you when you are proving riders. The following guidelines should enable you to master geometry riders and develop a sense of achievement and also enjoyment. Number 1, know all theorems and their corollaries. This includes all previous theorems that you have learned in grade 8 up to grade 10. In other words, make it a point that you learn all those previous theorems. In other words, there is no shortcut in Euclidean geometry. You have to make it a point that you master all the theorems that you've learned in the previous grades. That's why I said mathematics is like a building blocks. If you miss one block, it will be difficult for you to answer some questions. Still under this, where I said, remember what is the first point? You are supposed to know all the theorems and also the work from grade 8 up to grade 10. And during deductive reasoning, all new theorems are formulated through the use of known theorems. And that is important. And again, solving geometric riders in grade 11 requires a thorough knowledge of all theorems covered in grade 10 up to grade 10, as well as the new theorems learned in grade 11. In other words, you are supposed to learn all the theorems that you have learned in the previous grades and also previously. Number 2, always be motivated to do Euclidean geometry. With deductions of each theorem and solutions of each rider, we can experience the pure joy and the power of geometry as a logical, coherent, and also deductive system. And you make it a point that you can get the answers. Number 3, we know that it is not always easy to solve geometric riders. One of South African famous sportsmen once remarked, "The more I practice, the luckier I become. To a larger degree, success in geometry depends on the number of riders you are going to solve." In other words, if you solve more riders, you are going to do more problems in Euclidean geometry. Number 4, when you are given problems in Euclidean geometry, you need to read carefully the question. You can't just simply start without knowing exactly. You must make it a point that you understand the question properly. Make it a point that you understand that. Number 5, check carefully the given information. The given information, probably if you've got a different marker in your answer book, you can make it a point that you indicate those angles that are given, that they're equal. If you've got different color, you can also use them so that it can be much easier for you to master them. Number 6 rather. If you try to redraw a diagram, be accurate as possible, because sometimes it may tend to confuse you when you have drawn a wrong diagram or a diagram which is not convincing. Number 7, If you can't find a solution, you can turn upside down a problem. Probably it will be easier for you to interpret that. If you can't find a solution, make it a point that you turn a page upside down so that you can be able to get a solution. Remember, do not construct any problem in Euclidean geometry unless they give you a hint to do that, or they tell you that you are supposed to do construction. Because if you tend to draw that one, you are going to confuse yourself. Make it a point that you understand all of them. But if you check properly, number one, do you still remember theorem number one? You have to make it a point that you master that theorem number one. And if you don't master them, it will definitely be difficult for you to get solutions in this regard. Let me also give you some terms that we highlighted last time when we were doing this Euclidean geometry. Do you still remember, especially for those who might have forgotten, what is a chord, by the way? I said a chord is a straight line that joins 2 points on the circumference of a circle. And number two, I said a diameter is a chord that passes through the center of a circle. A diameter is a chord that passes through the center of a circle. Number three, a radius is a line joining the center of a circle to the point on the circumference of a circle. Number five, tangent is a straight line that touches a circle at one point. Then number five, it's a secant is a straight line that cuts a circle into 2 places. In other words, that line is going to cut into 2 places. Remember, radius is half size of diameter. Remember, in examination, like I said before, you are going to get 35 marks. And that 35 marks is coming from the work that you have done, you have done in grade 10 and also grade 11, and also the work in grade 12. So make it a point that you get your work in order. You are going to pass. Remember, if you don't do anything, you are not going to get marks. So you need to work harder for you to get marks. Good luck.
Alrighty, and that is how we wrap it up with Mr. Marubeni Mathematics today. Of course, your questions will be forwarded to the Kagiso radio teacher. He will review your questions, and upon his next lesson, he will touch into that. All right. Thank you so much, Mr. Marubeni, for joining us.
Oh, thank you so much.
We are making way right now for Progressive Talk with Ngamula Chauke. He's with you till 6. All right? Till 8, rather. Myself and Itubanda are saying goodbye at Dinkomo _ at Itubanda on Twitter. You want to say the last word, Mama?
Goodbye.